Bienvenidos, Ushamdi, and welcome to this Hut8 networking Techtorial on the ASA Firewall. In this module, Module 6, or the Techtorial Waypoint 6, we're going to be diving into the Modular Policy Framework, or the MPF. And this is really where we start to get into some of the more advanced concepts with the ASA Firewall. Now, before we dive into the modular policy framework, what we need to talk about is the difference between something being stateful, like an ASA firewall, and access controls that are stateless. So, for example, on a router, if I configure, and let's get onto the command line here, on the ISP router here, if I was to configure an access list, and this is irrespective of whether it's a layer 3 or layer 4 ACL. In other words, layer 3 being if I was simply matching on source IP, right? That would be a layer 3 ACL. Layer 4 ACL would be if I was looking for, port 80 or port 23 for telnet, right? So let's go ahead and let's configure a basic ACL here. So I'm just going to say access list, and we'll say 1 and permit from 209.165.200.0, excuse me, and then 0.0.0.255. So we'll make it a /24. So basically, that's an ACL that says permit traffic from this network, right? Now, this is just simply a layer 3 ACL. I'm basically saying permit any traffic from that source network, right? From the 209.165.200.0/24. So if I were to apply this to the do show IP interface brief, I can't remember which interface. I think it's gig 00. And it is. So if I was to go into interface gigabit Ethernet 00, and I was to say, whoops, need the IP in there, IP access group 1 inbound. So if I was to apply that ACL in the inbound direction, I'm basically permitting traffic coming from 209.165.200.0. So let's jump on, and we have to go, unfortunately, we've got to go into the smaller window here, right? And I'm going to telnet to the ISP router, 209.165.200.254. Now remember, this IP address, the real RFC 1918 inside IP address of this PC on the inside interface of the ASA is 10.0.0.10, and it's being natted to the 209.165, whatever IP address we got with our DHCP configuration. So let's go ahead and hit enter. And you can see I get the username prompt. So I'm going to say Travis, and then I'll enter the password of Cisco, and there it is. And I apologize, it is very small there, but as you can see, I'll try to make it a little larger here. As you can see, I'm on the ISP router right now. So, but here's the thing, is that this ACL, this is stateless. There is no connection table. There is no state table. There's no information being kept on the router about this conversation, because Telnet uses TCP, right? So this ACL is not looking at TCP sequence numbers. It's not looking at the FIN packets or the reset packets. It's not inspecting, right? It's not evaluating things at a deeper level other than to say it's checking every single packet that comes in, and all that it's checking in the IP header is the source address. And that's all that it looks at, and that's all that it makes its determination on as to whether or not this traffic or the traffic from the telnet session is going to be permitted. Again, in other words, it's stateless. the router with these basic access control entries and these ACLs, the access control lists, which have access control entries in them, maintain no state information about the different flows and conversations and communications that are taking place here, right? And so that is what stateless is. And that's the big difference between an ACL, which is just simply a layer 3 or layer 4 ACL, and the Cisco ASA firewall. So now let's transition back to the slides here, because this is what causes a lot of confusion. So you may be asking yourself, okay, well, you've shown me that the standard and the extended ACLs, when we apply those on a router or a switch or whatever the case may be, that those are stateless. So what makes the firewall stateful? In other words, how is it that the firewall is maintaining a connection table, a state table in which it is tracking actively the conversations that are taking place through the interfaces on the firewall for transit traffic, right? For traffic that is entering one interface on the firewall and then egressing out another interface on the firewall. And it's all done with the Modular Policy Framework, the MPF. This is what gives the ASA firewall its stateful characteristics and its stateful abilities and capabilities. It is all based on this MPF. And so I hope that right now you've got a clear understanding of what stateless is, right? Where it's not maintaining any of that connection information. It's not inspecting or doing a deeper inspection of what's going on, right? That stateless activity simply looks at the layer 3 or the layer 4 information and says, hey, is it port 80? Yeah, sure, let it in. You know, hey, is it from this source going to this destination? Sure, let it in, right? That's all that it's checking on a per packet basis. So what MPF does, the Modular Policy Framework, is it is going to maintain and inspect, right? It's going to do a deeper inspection of the traffic that is transiting the ASA firewall. And so here's how it does it. And I'm going to start from the bottom up. And there's 3 main components that we're going to talk about: the class map, the policy map, and then the service policy. And if you're familiar with QoS, quality of service, or if you've seen any QoS configurations, this may look very familiar, but remember, we are on an ASA firewall here. We are not on a router, we are not on a switch. So when we're issuing the class map command and the policy map command, it has nothing to do with QoS in this context here. It's all about the Modular Policy Framework. So here are the building blocks of the Modular Policy Framework. And this is also where we're going to get our answer to why ping will not work when we're trying to ping from a host on the inside to the ISP router. So the first building block, and I like to refer to this as the foundation of the Modular Policy Framework, it's the class map. And I've got the command right here where we can say show run class map, and you can put in the name of your class map. And so what is the class map? Well, the class map is the which. In other words, which protocols or which traffic, which VPN groups do I want to match so that I can then take an action on that traffic? I could inspect the traffic, right? So again, this is the foundation of the MPF house, right? This is the brick and mortar on the foundation on which MPF is built. And it's the class map, again, that is going to dictate what type of traffic, right? What am I interested in maintaining state information for? And this is where the class map comes into play. So if the class map is the foundation, think of the policy map as the framing, right, or the walls on top of which, or on top of the class map, where the framing and the walls are going to be built. So you can simply say show run policy map and then give the name of the policy map. And what does the policy map do? What is the policy map? Well, that is what it is. It's the what. In other words, what action am I going to take against the traffic that I matched in the class map, right? Remember the which protocols, right? Which traffic, which VPN groups, which traffic am I interested in maintaining and inspecting or doing something else with, right? And the policy map is the what. So we match in the class map, and then we take action in the policy map. Now, you can define more than a single action, and we'll talk about some of the different actions that you can take, right? You can inspect, you can police. In fact, I think I have, yeah. So you can inspect, you can change TCP connection options, right? You can shape the traffic in a QoS sense. You can police it in a QoS sense. And so the policy map is all about the what. What am I going to do with this traffic which I have matched in the class map? Now, the third and final component of the MPF house, right? This is the roof under which the walls and the framing and the foundation all sit. It's the service policy. And so think of the service policy as the overarching umbrella, right? That roof that sits over everything. Now, the service policy, we can apply it to a specific interface, right? So you could say, service policy, whatever, interface outside, right? We can apply it to the outside interface. Or we're interested in, our conversation is going to be around the global application of the service policy. And here's the thing. The modular policy framework and the extended ACLs, and I'm going to specifically call out, I'm going to say extended, because with the ASA firewall, something to keep in mind is that you can do standard ACLs, but it's in use cases where we're talking about maybe it's like a VPN group of some kind or split tunneling, right? When you're applying the access control, the ACLs, the access groups, or the ACLs that get applied as access groups to the interfaces on the firewall, when you're applying those, all of those ACLs are extended ACLs. You cannot apply a standard ACL to an ASA interface. It has to be extended. And I'm talking about the inside interface, the outside interface, the DMZ interface, right? All of those ACLs are extended. And so the modular policy framework, in conjunction with, right, in coordination with the ACLs, they work together, okay? So it's not, I'm going to either use, it's not an either or, right? You don't make the choice like, I'm going to use the modular policy framework and not the ACLs, or I'm going to use the ACLs and not the modular policy framework. That is not the case. So what I'm trying to say is the modular policy framework, which we've just looked at right here, the class map, the policy map, and then we apply it with the service policy command, right? The MPF is inextricably linked, right? It works in conjunction with the access control lists, your ACLs, which are applied to interfaces with that access group command. These things work in conjunction because if we didn't have the modular policy framework on the ACL, or I'm sorry, on the ASA, and all we were doing was applying ACLs, it would not be stateful. You would simply have a bunch of ACLs just like we do on routers, right? Or on switches, which we've already discussed as being stateless. And so the modular policy framework, and again, I want to make sure that I'm really, really clear on this because this causes so much confusion when learners are trying to figure out, well, wait a minute, do I do an ACL? Or how is the modular policy framework working with the ACL? I don't get that. So again, it's the modular policy framework that is going to give the ASA firewall its stateful attributes, its stateful capabilities. And the ACLs are also used in conjunction with the modular policy framework in order to control the connections that are going to transit. And we're not going to talk about management ACLs right now, so I'm going to stick with the traffic transiting the ASA. So let's go ahead now and let's take a look at the command line here, and we're back. And this, I reloaded it, but other than that, we have the same configuration we ended up with yesterday. The only thing I changed was we're back now. Let's get into privilege exec, let's say show run. I've added that small, unfortunately, this tiny little window. This MacBook now is hanging off, I think it's interface. It's either interface 02, which is not the DMZ. It's part of VLAN 99. So it's either interface 02 or 07. But needless to say, this Mac right here that we're looking at in this remote window is now in the inside, we'll call it the zone, the inside zone, along with this iMac here. And so, and that's VLAN 99. And so you can see this is what we've got. And so the only thing I changed was I removed the static IP, because that's how we ended yesterday's Techtorial. I put the IP address DHCP set route back into play, which means when we say show route, we do have a static default route, which we're getting from the ISP router because we're getting all of our addressing information from that router, and there is that information. Now, let's go ahead and let's say show run here one more time. And I killed it too early there. And let's come down to the section that we've discussed very, very briefly before. And we're going to stop right there. And so here, and this is by default, right? We didn't create this. This is here by default on the ASA firewall. Even if I was to do a write mem, write erase, or a configure factory default, this configuration is going to be there. Now, remember, the modular policy framework, what are the three pillars that we talked about? We talked about the foundation, right? The which traffic am I interested in matching, right? In other words, taking a look at later or taking action on later in the policy map. And so this class map that we get, and this is universal on the ASA, that you're going to see this with these names, right? Remember, we didn't create this. I haven't created this. This is by default, it's here. So that is the name of the default class map that we are presented with, right? And we're going to dig into exactly what this default inspection traffic means. But right now we're going to go over the different pieces. So the class map, by default, the name is inspection underscore default. Now remember, we said the class map is our foundation. This is where we classify, identify, right? In other words, pick which traffic am I interested in matching. in maybe taking an action on later in this policy map. And so I am matching something called default dash inspection dash traffic. Now, that is a pre-canned set of protocols that I can match, right? So when you say, and this is just default traffic types. So in other words, it's kind of Cisco's way of saying, hey, here is a list of a bunch of common traffic types that you would probably want to do inspection on, right? And so this is what we're going to be taking a look at, right? This is what we are matching. This is the which. Which traffic are we going to be grabbing, classifying, right? It's this default inspection traffic. Now, once the class map has been configured and we are done here and we've said, yeah, I want to match, right? I want to classify the default inspection traffic, you would then come down and configure your policy map. And in fact, I should have came down just a little further here. Sorry about that. Go ahead and ignore that right now for this DNS here. So the policy map down here, right? The name of the policy map is global underscore policy. And again, if you go to create a class map, you can name it whatever you want. It's just something that the name is descriptive that's going to make it easy for you to identify it later on. And it's the same thing here. The policy map global underscore policy, right? Very descriptive name, means this is going to be applied globally, right? And we'll see that when we get to the service policy statement, which is a little further down. It's going to be applied globally. In other words, globally means all interfaces on the ASA, right? And that's in the service policy, and we'll see that where it'll have that global keyword. But this is a great descriptive name. And so the policy map is all about action. Remember, the policy map is the what. What am I going to do with traffic that I have matched? And you can see here, policy map, we have the name of the policy map, and then how does the policy map know what traffic it's going to be taking action on? Well, under the policy map, we define the class, right, for the class map, inspection default. So where was this? Exactly. It's right there. So the policy map simply references the class map or class maps, right, because it could reference more than one, that you want to take action on. And so then now this raises the question, okay, I know how to pick, right? I understand the class map. That's going to classify or pick the traffic, which I would like to take action on in my policy map. And so now it's here in the policy map where we take the action. And here are the well, you can see it's basically one action, but what are these actions? Well, remember, the policy map can do all kinds of things. You could tweak the TCP options, right? So I could tweak the timeout of TCP activity, things like that. I can shape the traffic, but what we're interested in here at this level is this inspect. So I'm going to do an inspection and I'm going to apply, and you see all these names right here. This is one thing that's commonly confusing is when you see these names, it's not that you're inspecting FTP or NetBIOS. These are the names of the inspection engines, right? These are the engines under the hood of the ASA inspection capabilities that are going to run against the traffic that we have matched. And so it's these engines that are going to allow us to do deeper type inspections on things like remote shell or NetBIOS or FTP or DNS or TFTP, right? It's going to allow us to take a deeper look at that traffic using those inspection engines. And so again, the policy map references the class map and simply takes action, right? In this case, inspection action using these engines, these engines on the traffic that we have matched. Now, let me clear the screen here because we're going to have to make a minor adjustment. I'm going to come down a little further. So those are the first two pillars. And then the third one, right, this is pretty straightforward here. We have the service policy, right, which is referencing what? The global policy map, right? So the service policy that I'm going to apply is going to reference the policy map. And how am I going to apply that? Am I going to apply it to a single interface? Am I going to apply it to multiple interfaces? Or am I going to simply say global? And again, it's the modular policy framework, what we just covered here. This is what gives the ASA its stateful capabilities and its stateful characteristics, in that it's going to track via the connection table, right? It's going to be creating connection objects in the connection table. And remember, the connection table is synonymous with the state table. Those, when you say connection table or state table, those are the same things. And we'll see the show connection command and show connection detail here shortly. But again, we need to understand conceptually, what is the modular policy framework? Where is it located here in the configuration? And again, remember those commands. If I were to say show run class map and hit enter, right? I don't have to put the name in, but if I say show run class map, I could have said show run class map and then typed inspection underscore default, right? But since that's the only class map that we have, you can simply say show run class map, and it's going to show me that foundation of the modular policy framework. Now, here's what's interesting is when we look at the class map, you see that it says match default inspection or default inspection traffic. So if I get into global config, and let's say that I wanted to go into class map inspection underscore default. And so here I am. I'm in the class map where that match command is located. And so if I do a question mark here, right, this is going to show me what exactly the default inspection traffic is going to consist of. And so let's take a look here, and I'm going to pull this line right here. We'll draw that line right there because that's what we're interested in. I could say match any, right? So match any packet, but that's not what we're doing. We're matching the default inspection traffic. And so here it is, right? It's pretty straightforward. You can see we've got HTTP, right? RSH, SQLNet, WAS, TFTP, SMTP, right? So we've got all of these different protocols, and you can see they give the port number here, the FTP, right? And so we've got all these different protocols here that we're tracking, that we're maintaining the state information for. And you can see that we've got ICMP. This is what we want to match. These are all the things that we are matching. And this ICMP one right here, let's put a little asterisk here. Because if you're looking at this right now, you're saying, well, wait a second, ICMP is not working. You're telling me that we're matching it here. And I'm going to say, yeah, we are, right? But remember, matching it with the class map is different than taking action on it. And that policy map is what is going to dictate what I'm maintaining the state information, the connection table, the connection objects that are going to get created that go into the connection table. Those right now are dictated by the policy map. That determines whether I'm interested in the traffic at a deeper level or I am not interested in the traffic, right? So here's everything that by default we are matching, right? That's how you can see what that default inspection traffic is all about. So now that we know what the class map is interested in matching, and you can see here this WAS is matching TCP every single port, right, for WAS. So pretty extensive. Okay, so let's clear this here. So that's what the class map is matching. So remember, we can also see the policy map. If I say show run policy underscore map, policy dash map. If I say show run policy map, you can see this one here. We're just going to ignore that one for right now. But this is the one that we're interested in here. So remember, we just looked at everything we're matching, right? In the class map, we saw it here. And we saw that ICMP is actually listed there. But remember what I told you. Matching the traffic in the class map, that's the first step. That's our foundational step. Once I match all the traffic, now I take action against the traffic. What is it that I want to do? And if I'm not inspecting it, right, if I'm not taking action against the traffic that I have matched, then I am not creating connection objects in the connection or the state table, right? The connection table and the state table. It's not going to happen. And so let me ask you this. Do you see inspect ICMP anywhere in here? We do not. And again, remember, we're starting from a default configuration. And so this is why we can't ping through the ASA into the inside interface, out the outside interface to the ISP router with an echo request. And that's why we're not getting an echo reply back, is because there is no state information being maintained about ICMP. Now, ICMP in and of itself is a stateless protocol, right? The ASA is smart enough to look. When we say inspect ICMP, the ASA is smart enough to get that source IP and destination IP and the port information. It's smart enough to look at that information, create an entry in the connection table, to create a connection object in the connection table, so that it understands that when the echo reply comes back, that it knows to let it through. Because you'll notice something. Do we have any access lists, and I'm going to use a word here, I'm going to stress this word. Do we have any access lists that we have explicitly defined? Have I gone in here on the ASA and created extended ACLs and then applied those ACLs to interfaces on the ASA? We haven't, right? We haven't. So by default, remember what I said earlier on. We talked about the security level. Remember, the inside interface on the ASA, the inside interface, and I'll just put I for inside and we'll put O for outside, is security level 100. The outside is 0. By default, if I haven't explicitly created any ACLs and applied them to interfaces on the ASA, then by default, traffic from a higher level security zone can transit to a lower level security zone. And we'll just put www, maybe it's a web server out here, right? So this is by default, but this will change. And again, remember, we haven't done any explicit ACLs. And so it's at this juncture where the GUI actually provides some benefit here. So if I was to say show access list, right? Because this is how you see the ACLs. And there you have it right there. There are I don't have any ACLs explicitly defined. Now, you're probably wondering why I keep stressing on explicit. And I'm going to have to break it up because I don't want to make sure this doesn't run for, a couple hours. So we're going to be breaking it up. I'm going to briefly touch on the ACLs that are implicitly on the ASA. And remember, the difference between implicit and explicit, let me make sure we're clear on that here. So if I come over here, put the password in, if I say show access list, and I'm on the router, right? But again, this is going to prove the point. So this is an explicit ACL. You remember me going in and creating access list 1, saying permit all traffic from the 209.165.200.0 with a wildcard match. You see we've got all kinds of matches going on here, right? This is explicitly created. I explicitly went into global config, sorry about that. I explicitly went into global config, typed in access list 1 permit, and the rest of the syntax that was required. This is explicit. Now, what is implicit about this ACL? Exactly. It's implicit that somewhere beyond the ACE entries that I explicitly created, that the very last entry, and I'll just put last depending on what the sequence numbers are, the last entry is what? Deny any. And it doesn't show up here, right? Why doesn't it show up? Because it's implicit. It is implicitly inferred, right, that this exists. So we don't see it because it's implicit. If it's explicit, we do see the entry. And the same is true on the ASA. So if I transition, and actually we're going to tackle this, I don't want that there. We're going to tackle this from the GUI because, again, you don't see it here. When I say show access list, you're probably saying, well, wait a second, you're telling me that there's ACLs here and that they're implicit, but I don't see them when I say show access list. And the reason that you don't see them is the same reason that you don't see the implicit deny any at the end of an ACL, is because it's implicit, right? It's assumed that it's going to be there. And so when we pull the GUI up here, and you can see the GUI's been tracking what I've been doing here, and we've looked at some things, and so it says, do you want to refresh? Because obviously some changes were made, so I'm going to say yes, and we'll put in my password here of Cisco. And again, this is where the GUI can be of great benefit. So how do we do it? We go to configuration. I come down here, firewall was already picked, and take a look at the access rules, right? In other words, the ACLs that exist by default. And let me see if I can't stretch some of these things out here just a skosh. All right. So, and again, I apologize. This is a little small here, but not a lot of output, so it should be easy to follow. So remember, I said we've got the ASA. We've got the inside interface. We've got the outside interface. Security level 100, security level 0. So when I say by default that traffic is allowed from a higher security level interface to a lower security level interface, and we refer to that as outbound traffic, right? This egress, outbound traffic from the higher level security interface to the lower level security interface is allowed because of this implicit rule. So there's one implicit incoming rule into the interface, which means if I had a switch hanging off over here and we've got all these hosts, all of their traffic, right? Do some X's here. All of the traffic from all of these hosts, when it comes in, that is ingress, inbound, right? And that is the direction in which this access rule, or this ACL, this implicit incoming rule, is defined. And so let's take a look. There's the sequence number, right? And so it's any source traffic. So any traffic, right? Any ingress, inbound, incoming traffic into the inside interface, destination, going where? To any less secure network. In other words, any interface with a lower security level. And so it doesn't just have to be 0. If we had a DMZ hanging off over here, right? Now I've got some web servers, www. And let's say that the security level is 50. By default, right? This is the implicit rule that you do not see when that show run output is run, or even the show access list. And so the service, right? What protocols? I'm allowing IP. Remember, IP is everything. IP is like the umbrella or the top level, and under that you've got TCP, you've got UDP, you've got ICMP, you've got everything, right? Just remember that. If you see IP, that means that everything from a protocol perspective is allowed. And what is the action going to any less secure networks? It is permit, right? Great description here. Implicit rule, permit all traffic to less secure networks. Now, we've also got this global rule, and this sort of turns into a catch-all, right? And it's an implicit rule that shows up at the end of the other access rules. And we'll get deeper into this later on, because again, I'm dedicating a module to this. In fact, the next module is dedicated to this. But I want to make sure we cover this, because it's not good enough just to say, oh yeah, by default, you can go from a higher level security zone to a lower level security zone. Because as soon as I apply an ACL via the access group command to that interface or that interface, like let's say we want to do port forwarding, we're going to be doing that, right? So I'm going to have to allow traffic to come inbound on that outside interface. So we're going to have to put an ACL there. That's when the default behavior changes. And it's no longer correct to say that traffic from a higher level security zone can by default go to a lower level security zone. Okay? Because as soon as I put an ACL with the access group command on the inside interface of that ASA, this implicit rule saying that, oh yeah, all traffic can go from my inside zone to any lower zone, no longer the case. But it's critical to understand why this is the case now. Because when we go to build and put those access rules, those ACLs, onto the interfaces of the ASA, then you'll understand why. Well, wait a minute, why can I no longer just randomly have all my traffic going outbound to lower security level interfaces, right? You'll understand why that is. So this is also important. So the outside interface, remember I said the global is the catch-all, right? And this comes into play right here. The outside interface says 0 implicit incoming rules, right? Because by default, can traffic from a lower security level interface just simply make its way through to higher level security interfaces? And the answer is no. So from the outside here, right, this ISP router, I simply can't just SSH to devices that may be sitting here on the inside zone, right? Because this no implicit incoming rules, you can see it doesn't say any more secure network here. It doesn't say IP. It doesn't say permit, right? So there is no implicit rule for interfaces that have a security level of 0. Because 0 is what? Yeah, that is the lowest possible security level. If we created a management-only interface, which we're not going to do right now, but if I did, it would be 0. In addition to that, no traffic would be allowed to transit. It does not routing traffic through the management-only interface, but it would be 0. You can go no lower than 0, right? So we are at the bottom, excuse me. And so what does that mean? So if there's not an implicit rule for the outside interface, then how is it that traffic is getting denied? And if you're looking down just a little further, you got it, right? It's this global implicit rule. So you're probably saying, well, wait a second, Travis, how come it's not denying traffic up here? Well, remember, the global implicit rule is applied to all ASA interfaces as the last rule, right? But if the first rule allows everything, do we ever get to the last rule, right? No, because everything is already implicitly allowed into the inside interface to any lower security level interface on the ASA, right? However, with the outside, it's already at the lowest security level, 0. So there is nothing allowed, which means there's nothing permitted, but there's nothing denied, but there doesn't have to be anything denied because this catch-all global implicit rule, which is going to be the last rule that's looked at on every interface. And so what does this rule do for the outside interface? Traffic from where are we at here? Source. Traffic from anywhere going to anywhere. And what kind of traffic? All traffic is denied. And this is an implicit rule. And so this is why you don't see these when you do the show run or the show access list, but they are here. And thank goodness for the GUI, which allows me to see this information. So we do have ACLs that are in play, but they are I keep mispronouncing that. They're implicit. They're implicit, right? They're not explicitly created and applied. They are implicitly applied, which means it's assumed that they're applied. And this again is by default. And so right now when I make that statement that you can go from any higher level security zone to any lower level security zone, that is a true statement. If I was to add in, right, and let's do this here. We'll step away for a second. If I go into interface, let's say int VLAN, and we'll call it 50, and I'll say IP address 172.16.1.0, 255.255.255.0. We'll go ahead and say no shut, bad mask, 16.0. And all right, let's just do this. We'll do the whole /16 here. IP address 172.16.0.0. Whoops, 255.255. Oh, apologize. I thought I did 1.1. My bad. 255.255.0, and that's why we got the mask thing. So we're going to give that IP address to the interface, and we're going to name it, right? Name if DMZ. Not DMX, but DMZ. Now, fortuitous failure here. I have the base license on this firewall, which means, and the error tells you right away, that the base license will not allow me to configure more than 2 interfaces with name if without the no forward command on this interface, right? Now, what this no forward command means is I can say no forward, and what I'm going to have to do is I'm going to pick the interface to which I do not want to forward traffic. So from the DMZ, I wouldn't be going to the inside interface. So I'll say interface inside, whoops. And what did we call it? Oh, what's the VLAN? Sorry. Interface VLAN, and we used 99 for the inside interface, right? So I'm going to say no forwarding traffic. I said name if, and what did we call this? I said DMZ, right? Yeah. So you can see DMZ set to 0 by default, but what if I want to change the security level? We'll make it 50. Now let's go back to the GUI where we should be greeted with that dialog box saying, hey, you made some changes here. Let's refresh. So I'm going to refresh it, and what are we going to see change up here? Bingo. We've got a new access rule, right? Another implicitly applied. We're not going to see it in the running config, but it's implicitly applied right here, right? And so again, traffic from any source in the DMZ, so traffic that shows up at the DMZ interface on the firewall can go to any less secure networks. And every single interface that I would create, as long as it has a security level greater than 0, will have this implicit rule created for it. And that is, again, why you can say that by default, traffic from a higher level security interface can go to a lower level security interface. And again, you can see how the ACLs, right, are inextricably linked. They are very related to the modular policy framework, right? So back to the modular policy framework. We had to take a little detour there, but back to the modular policy framework and the conversation that we were having on ICMP and why ICMP is not working. And the reason that it's not working is because it's not being inspected. There is no state information being created by the ASA policy map. It's not creating a connection object in the connection table, the state table, that's going to allow the return traffic to come back. Because that might be what you're asking yourself is, wait a second. So you just told me that traffic from the outside cannot come in to the inside. So how is it that HTTP is working? And again, it's the modular policy framework. It's going to create a state entry in the connection table, right? A connection object in the connection table that's going to track the TCP sequence numbers, right? Or the ICMP source and destination IP address and the connection information, so that when the return traffic comes back, it allows it to come through. And it protects me on the inside. Because what I could do here, right, is I could go off and I could create an ACL. But I don't want to do that. I want a stateful approach to be taken here. So how do we do that? It's very simple. First, let's confirm that it's not working. So here I am. I'm going to say ping 209.165.200.254, right? And is the ping working? No, it's not. Because, and actually, if I was to go over to, so outbound, right? And we'll come back here. So if I say on this ISP router, and Cisco is my password, debug IP packet, right? So I'm debugging the IP packet. So let me ask you this. And actually, let's just go ahead and say you all real quickly here. We'll stop it because we've got enough information, right? So let me ask you this as soon as this stops. Hopefully I caught it before we're in a situation where I have to power it off. Oh, come on now. Hoping it's going to cooperate here. Because what I want to show you is this again proves, okay, there we go, finally. All right, so this again proves the point that outbound, so traffic from a lower level security interface is, and I'm sure we'll go back up to the beginning here, so that traffic from a lower level security interface is allowed outbound on the ASA firewall. And so we are looking for, we've got the source and destination, IP, feature access list 47, check 109. So we can see that traffic sourcing, oops, sorry, I want to make sure I highlight the right thing here. Traffic sourcing from 209.165.251, that is traffic. That is the ASA traffic. You can see it was destined to 81.161 and not the, here we go. This is what I'm looking for, something a little more reflective here. Sorry about that. So again, this proves the point that traffic is being allowed. Transit traffic is entering the inside interface on the ASA, right? It's being natted on the outside interface and allowed with a destination of 209.165.200.254 to show up here on the ISP router. So this proves the point, right? It proves the point that the traffic is being allowed out. But what don't you see? We see a whole bunch of IP, right? But do I see ICMP? Without an inspect, if the traffic shows up at an interface and it's not being inspected, no connection object is going to be created for it, and it's not going to be allowed. So let's transition back to the ASA and let's solve the problem here. So how do we solve it? Well, we simply need to modify the inspection setup here by adding in ICMP, and you'll see how many things we can actually policy map global _ policy. So I'm in the policy map, right? If I say inspect, whoops, sorry. If I can spell, or did I get into the right policy map? And oops, sorry, I left out the class map. I'm going to go to class map inspection default. Or actually, no, we don't. And hold on. Confusing myself here. So in the policy map, I have to go under the class map, which is where I would say for all these things that I'm matching, right? What inspection engines do I want to turn on? And there it is. There just happens to be an ICMP inspection engine. So again, we rotate back to this window here. It's not working, and I'm pretty sure I'm going to have to, it may click on right away, or it may not. I may have to stop and then restart. So let's say inspect ICMP. As soon as I hit enter, we transition back over here, and yeah, so we're going to have to say Control C, and we're going to have to start it off again, and now take a look. Now it's working because it's allowing the ICMP echo replies to come back in. So while all traffic for which a connection object is going to be created going outbound, it allows that traffic to come back inbound. If I was to pull up Safari here, and let's jump off this page and say 209.165.200.254, right? You can see it says you're not connected to, oh, and you know what? I've got to leave the wireless on. So yeah, it's not going to work. And let me pull this guy back up here and see if we get, because we had this working the other day. So I was going to try to pull up the HTTP web page. So if we go to 209.165.200.254, it says Safari can't open the page, right? So we'll come back to that. So with the pings though, take a look. ICMP is now functioning. If I pull up the firewall and say show connection, right? Here are all the connections for which I maintain. You can see we've got all kinds of DNS, right? Because if it's trying to go to the 71, that's the Verizon DNS server, because now we're on this iMac here, which still has configuration to get to my outside Verizon service provider in DNS servers. You can see port 53, right? Where is it showing up? On the inside interface, and there's that random high port, okay? And we can see all that information. Now, there's our TCP connects, right? So we're going from the inside, trying to get to the web server at 81.161.59.132 on port 80. And so this is the stateful information. This is your connection table. Here are the connection objects, which the ASA is tracking to make that determination as to whether or not traffic is allowed out, to go from inside to outside and a connection entry to be created, and B, whether or not that traffic would be allowed coming back. Because when the traffic, and there's an order of operations concern here, right? When the return traffic is coming back for these ICMP echo requests, right? So here's the ASA, inside interface, outside interface, right? We've got, all of our hosts out here plugged in on the inside. We'll say I for inside, 100, O for outside, 0. So I'm pinging right now, and I'm pinging this router over here, the ISP router. The echo reply goes out, and the echo request comes back. And so the question is what is evaluated first? Is it the state table, the connection table, right? Is it the stateful information that's looked at first, or would it be the ACL? And we have the answer to our question already. It's the state table. Because what is the implicit ACL on that outside interface right now? Yeah, it's referencing the global policy, which says deny any. This is what's protecting us right now. It's the state table that is saying, I see traffic coming into the inside interface. My service policy told me to apply the policy map to all interfaces on this ASA. And so when traffic shows up here, for which the ASA is going to inspect and create a connection object, that stateful activity of creating a connection object. When the ASA creates that, if it's allowed on that inside interface, then we're allowed to go out that lower level security interface. And when the traffic comes back, the ASA first checks the state table, the connection table, for a connection object, because it's looking to see, do I have an entry that I can look at and say, yeah, that ICMP echo reply coming back into the outside interface, I have a state table entry in here, and I am going to allow that to come back into the ASA from a lower level security interface to the higher level security interface because it was initiated on the higher level interface. And I have state information about that. And so we know right now that by default, the state table is looked at first because there is a deny any on that interface implicitly defined. Because what I can't do is I can't come out here to the ISP and ping a host that's back over here. It won't be allowed because the echo request, and let me change colors. I'm terrible at changing colors, so I apologize. The echo request, if it was to come in here, right, what is the ASA on the outside interface going to check? Yeah, it's going to check the state table. And it's going to say, yeah, unfortunately, I don't have any connection objects that state that you can come in this outside interface. There's nothing existing here that's telling me that, yeah, you've already been communicating and I'm going to poke a hole in this inside or this outside interface here to allow that traffic to come in. It's not there. There's no state information. The traffic is dropped. The traffic is dropped, right? And again, that's what's happening by default. So the state information is looked at first, okay? All right, so let me go ahead and clear the screen here. And I think that that is going to do it. If we say show run, let's take one last look. Or actually, I could just simply say show policy map, and I can put the policy map name in here, which is, I'm drawing a blank, global policy, global underscore policy. And I cannot do that. Show policy, no, policy list. Oh, show run. Sorry, I left the run out. Show run policy map global underscore policy. Too many things to keep at the front of my mind. So that way we don't see that other one that we want to ignore. So here we go. And what is different about this policy map now, right? What is different right there? It's the inspect ICMP. Because now traffic initiated from the higher level security zone, the inside security zone, going to the outside security zone, it's allowed, and I now have state information being maintained for ICMP. And hopefully you see that. Hopefully you've got a good, solid understanding, and I am really, really hopeful that this explanation of how it is that the ASA is a stateful device and what it is, right, that is making the ASA a stateful device, and the fact that the ACLs work hand in hand. They are inextricably linked. They are tightly coupled with the modular policy framework. And so this is a good stopping point, and the next module that I do is going to be on those access lists. We're going to now start to combine the ACLs with the modular policy framework, and we're going to see that this default behavior here, and let me refresh this real quick, this default implicit behavior where anything from a higher level security interface can go to anything on a lower level security interface is allowed. that will no longer be the case. And again, that's one of the confusing things for learners, is that you hear that when you're learning first about the ASA firewall, you hear that statement that, oh yeah, you can go from any higher level security interface to any lower level security interface. And that is true if and only if you have not applied explicit ACL rules to those interfaces that you're talking about. And so that is what we're going to be tackling in module number 7. All right. Again, I really appreciate your time. I hope it was worth it. I'm going to leave the question section open on this video on YouTube, so please feel free to give me your feedback. Did this make sense? Did it not make sense? Was it clear? Was it not clear? And again, really hope that it was clear. And that last bullet there about the global policy, we saw that. All right, well, this concludes Module 6. Again, a monster module, but this is one of the most important topics when we discuss the ASA, is the Modular Policy Framework. This is what makes the ASA a stateful device. All right, thanks so much for watching. Hope to see you in Module 7.